Look up, man. You think you're very funny?
Do nothing.
Where's the boss's money, man?
Didn't do nothing.
Where's the freaking boss's money, man?
Didn't do nothing.
Look at the boss, man.
The boss.
Hey, yo, Vince, man. You remember me, man?
I swear I have the money, man.
Whoa, man, you alright? I'm a mango, man. And I need my money, man.
I swear I have it right now.
Three
It's
months,
in my
man.
pocket.
I need my money right
It's in my
now.
pocket.
Ronaldo, search this man.
Yo, watch it, man.
What guy here, man? You trying to play around with the money, man? Where's the rest of the money, man?
I swear I had it.
Where's the rest of the money?
I'm sorry. I was hungry. I had to.
Boss, what we gotta do with this fool, man?
I had to.
What are we gonna do with this fool, man?
I never get tired of these mangoes, man. But if there's one thing I get tired of, Vince, it's people playing with my money, man. I hate that, man. What am I gonna do, man? What am I gonna do? Ronaldo!
Get the sling.
I got you, boss.
Gotta get out of here, man.
Here it goes, man.
Whoa, hold up. Did you see all the kinetic energy being used right there? What's that? You don't know what energy is? Isn't that one of the physics concepts you were supposed to learn in class this year? Oh, I see. You weren't listening. Well, I think I might be able to help you. I have a friend who might be able to teach you a thing or two. Let's call in the physics whiz to teach us about energy.
There are 4 types of energies. One of these energies being kinetic energy, represented by EK, is energy created by motion. Another type of energy, which is a potential energy, is gravitational energy, represented by EG. This is energy created from having a distance off the ground. Another type of energy is elastic energy, which is another form of potential energy, which is created by an elastic item being stretched, giving it its name, elastic energy. And that type of energy is represented by EE. The last type of energy is thermal energy, which is heat created by friction. And that type of energy is represented by ETH, or thermal. And now let's see what types of energy Vince creates in this next scene.
Alright, based on what you just learned right now, there are 3 major energies being used in this situation. The first 2 are gravitational and kinetic energies. Gravitational because Vince has a height off the ground. Kinetic because he's in motion. And as he goes along, he loses gravitational and kinetic because he is losing height as well as losing speed as he goes around the corner. And in his final position, he has no kinetic and no gravitational because he is on the ground as well as not moving. And so all energy is converted to thermal as he stands still waiting for his enemy to pass. Now let's see if there's any other situations where our 4th and final energy is being used.
There he is!
Oh, perfect. Good thing Orlando brought his sling, because as soon as he started to stretch it, it began to gain elastic energy. And as soon as it gets to its max elasticity, and then he lets it go, it will lose elastic energy. And then it will eventually get to a resting point and have no elastic energy, but instead have all thermal energy. Just like Vince did when he was at rest at the bottom of the stairs. Oh, but I wonder, is there any way to show these types of energies? Let's ask the physics whiz to see if he can help.
Now I'm going to show you how you can show these energies on a graph. The first type of way that you can show energy on a graph is with pie charts. Let's say that an object is rolling down a hill, a ball. At the beginning, at the top of the hill, the object has fully gravitational energy because it is not moving and it has height off the ground. In the middle of the hill, the object has two types of energies. It has gravitational energy from height off the ground because it is halfway down the hill, and it has kinetic energy because it has picked up speed from rolling down the hill. In the last part, at the bottom of the hill, the object will have fully kinetic energy because it has already reached the bottom, but it is still moving. So this pie chart is going to have fully kinetic energy. The second way to show this on a graph is with bar graphs. These graphs look like this. It has each type of energy: kinetic energy, gravitational energy, elastic energy, and thermal energy. And split into 5 sections usually. So at the top of the hill, this ball will have fully gravitational energy, which is why the only bars in this graph is under gravitational. And the objects that are part of this system are the ball, the hill, and the earth, because it is pulling the object down with its gravitational force. And in the final graph, this chart is exactly the same as this one. So at this point, the ball is at the bottom of the hill. It is moving, but it does not have height off the ground. So at this point, it is only going to have kinetic energy because it is moving and no other energies are acting on it at that point.
Alright, he demonstrated how to show energies through bar graphs and pie charts. But I'm also wondering, is there any way we could show energies in maybe a quantitative form, like an equation or something? Maybe we can ask the physics whiz again to see if he can help us. One last time.
Right now, I'm going to teach you what the equations are for each of these types of energies. For kinetic energy, the equation is EK equals 1/2 times mass times velocity squared. The equation for gravitational energy is EG equals mass times gravity times height. The equation for elastic energy is EE equals 1/2 times K, which is the spring constant or the elasticity of the item that is being stretched, multiplied by the distance that the item actually stretches, x squared. And thermal energy is just the percentage of energy that is lost due to friction.
Okay, now that you're all caught up on energies, maybe next time you'll listen to your teacher in class. That way you don't have to listen to me talking all day. Alright, now back to a regularly scheduled program.
Oh, you get away from me, man! The mango, man! Oh, you were wrong, man! You were wrong!
Oh no!
Rolando, pick him up.
Okay, boss.